Hi, I'm Simon. I'm with Dell Technologies, and I'm joined by Brandon, Paul, and Marianne from Diskover Data. What we're going to show you right now is the new data orchestration engine from Dell Technologies. Why it's really important and really interesting and really exciting for media organizations. So media organizations have been enriching the metadata of their content and maintaining databases of their archives for years and years. And they've always been looking for ways to improve the efficiency of enriching that metadata. Now we find ourselves in the new world of AI and other algorithms and other machines with different industries and different technologies are also wanting to enrich their archives of data, whether that's video files, image files, or PDF data files, all sorts of examples of different unstructured data. So the technologies that data scientists are using is now, if you like, coming back full circle and being available to media organizations in their quest to enrich the metadata of their existing media archives. And what the data orchestration enables us to do is to build pipelines with the large language models or the image recognition engines of our choice and enrich that metadata. And the really exciting thing is that as a user, as a broadcaster, as an archive owner, you're not locked into any one technology, to any one LLM. If a new LLM or a new training model is released, you can embrace that and use that and bring that into your pipeline as well. So to illustrate that, we're going to show you a couple of data sets and a couple of ways that the pipeline in the orchestration engine is being used to enrich that data. So what you can see on the screen in front of you is a really, really simple pipeline in the orchestration engine. You can see we have a data set represented in that node at the left-hand end. In the middle, we have a frame splitting algorithm. And then at the final part, we have an object detection and bounding box algorithm. Now, we've used some videos from the Artemis 2 space mission here. And the first thing we want to do to those is break up and pull out some frames. We don't want to waste compute power or resources or time analyzing every single frame in that video. So the first thing we're doing is pulling out representative frames. Every time the scene changes, we'll take a reference frame of that, and then we will do some work on that. And there on the screen, you can see in front of you some of those reference frames that have been extracted from the video that we took from NASA. Now, once we've got those frames, we can push them into the next stage of the pipeline, which is to do object detection and bounding box. So we can see what we've got in the image. And a really great example of the image is this one here, showing some people, some persons in that image. And you can see the bounding boxes around those objects in that image. That's very, very basic object detection. But it's a limited algorithm. It doesn't know everything about space rockets or space travel. So the only thing it's identified in that image is the people, the astronauts. So how can we take that further? How can we do more advanced object detection or more advanced image analysis? Well, great. We can just choose a different algorithm, a different model. And here's a much more complex pipeline that we've done that enables us to do exactly that. So this pipeline starts with the same data set. The first thing it does is breaks that data set up into those keyframes, again, just like we did before, breaking up the keyframes to give us a representative sample of each scene in the video. And then what we do is pipe it into a code node. And that is some code that we have written, and the developers, the data scientists, can use whatever code they like to extract some information from that image that we created and create a prompt that we then push into a large language model. Now, we've chosen a particular large language model here. It's representative of what we want to do. It's from NVIDIA, and it does a great job. So we take those still images, we craft a prompt programmatically, and we push that into the large language model. The large language model does its thing. It analyzes the image and then outputs that data. And we've specifically asked the large language model to output the data in two ways. We can have a look at that right now. We've asked it to give us a free text description of the image, which, if you like, is human readable, so we can see straight away what that image is. And we've also asked it to give us some key value pairs, which is a much more, well, it's semi-structured data, a much more structured way of being able to create that metadata and enrich that asset in a programmatic way. So you can see on the screen in front of you, that is the description that the large language model has given of that image, which is, as you can see, is a whole level above the straightforward object detection algorithm that we had first of all. And then also embedded in the metadata of that image is key value pairs, much more structured, or what is actually semi-structured data, isn't it? It's a JSON set that gives you a programmatic way to access the metadata on those assets. Now, this is really, really interesting for broadcasters and other holders of large archives because it gives them a way of enriching their metadata on their existing archives, but also gives them a way of taking advantage of any new models that are released in the future. Now, you've noticed that we've been doing all this within the user interface of the orchestration engine, which is a really awesome thing to be able to do, but it only gets you so far. The orchestration engine, as it turns out, has a really strong API, which means that we can access all the things that we've just been talking about. We can access programmatically from external applications. And this is where I hand over to Brandon.
All right, so Brandon with Diskover here. We're going to demo just quickly how we're able to push data from the Diskover platform into the Dell Data Orchestration Engine for additional metadata analysis. So we can see here that we have some ECS object storage where we have some content, and we've developed a pipeline in the orchestration engine that uses that same data set as its source. So in the Diskover platform, we can maybe review some music one or some movie one sheets, and we can choose to submit this to the Dell Data Orchestration Engine. And we'll choose our specific pipeline that we would like to submit this to. And this will programmatically initiate this pipeline from the Diskover platform into the Dell Data Orchestration Engine. And so shortly, we should see a new in progress component coming across here, which will just show that we've initiated the transfer from the Diskover platform to start the pipeline within the Dell Data Orchestration Engine. And so we see this in progress. Now, this does take some time. So we'll take a look at a previous example execution where we've done this analysis. And so if we look at the output image from the pipeline, we can see that this is just a simple movie trailer poster, essentially. And within the item metadata in here, we can see the same level of a description. So it's a movie poster from the film No Peace, No Peace, and some breakdown of what else is on the poster. And then additionally, we are also harvesting that same LLM summary metadata. So we get a breakdown of the cast, the genre, the main character of the movie, release date, title, and some scores on the quality of the image itself as well. So this is a demonstration of how the power of the Dell Data Orchestration image can be enhanced programmatically using other third-party applications.